of a lab. Huh?
Zero classes.
No, you had classes yesterday?
No.
Maybe not for PPC. No, PPCC did because the kids
Oh my
in my PSAT group are complaining
I
about
almost
it.
missed my meeting.
So I missed all of yesterday.
No, what? I was doing this.
Okay, I'm gonna back way up for a second because not everyone listens to me apparently.
It ain't that we just listen to you.
I
You
talked
weren't born.
about it before. The
You weren't
only one
born.
that probably has an excuse is Jesus because he's been gone. Well, he is Jesus, especially to baby Matthew or whatever his name was. I don't remember. Oh wait, I already have Canvas up. Let me exit out of my PowerPoint. Slackers. Okay. Yes. I told your mom I was going to start sending you weekly emails. I got to remember to do that.
Me too.
We had a good conversation about you. All right. So yesterday, because I reminded you these last couple days that it was an asynchronous day. So those of you that don't know what asynchronous means, it means it's not live and in person. All right, like Mondays, because we were here giving the 11th graders the PSAT. So this is a video. It's like an 8-minute video of a teacher that I steal a bunch of work from because she's really freaking smart and amazing, and really kind of runs a lot of this country's AP Environmental Science class. Well, I'm not reinventing the wheel. All right. So this, if we were to do it in person in class, it would be about a 2-hour lab, which is why I said it would have to be like on a block schedule. Plus, it's like a 48-hour thing where you would have to come back and check on it. So she cuts the whole lab down into 8 minutes, and I don't have all the equipment to do this lab anyways. And you guys were supposed to take some data and information from it and calculate NPP and GPP and respiration. All right, the calculations are fairly simple, I think. I think the biggest issue is sometimes people divide when they multiply or multiply when they divide. Yeah, it is what it is. All right, so this is what it looks like. This is the link to the video. All right, and then you had to answer some questions about it. Honestly, I even did this myself to make sure the link and everything still worked and it was still all the same. She didn't like change her video on me. I did this in like 20 minutes. So it wasn't an insanely intense, like, there's not even graphing. Okay, yeah, but this is not stuff I work with all the time. Because it's part of what you get tested on. That's why I'm making you do it. You have to understand how to calculate it. It's one of the things you might have to calculate on the exam. I tried to yesterday. All right, so it goes into some independent dependent variable, which hopefully you guys know what that is, what constants are. Oh my God. And then it has you fill in her data. And for those of you who don't know, this says parts per million. Parts per million is the exact same as milligrams per liter. They're interchangeable. There's no conversion. Okay. It's like 12 inches is 12 inches. They mean the same thing. The equations are in these boxes, right? So respiration, R equals initial minus dark. Initial minus, which one's dark? This one. So you'd be using the information from these two columns. Yeah. Huh?
Me too. Does anyone have a tennis ring?
No, but I have a senior one. Oh, you think I can throw? Oh.
Don't you play softball? Or
No.
don't you teach? What was it?
I like failed out of softball, if that was such a thing.
And it's virtual.
You have bad eyes?
Pretty much.
No.
Like, I really want this information to go in.
He's just gonna absorb it.
Just go in.
All right, so it gives you your equations there. Now, you guys have all taken math classes. You've all had to do like y equals 2 times x and then solve for x, right? Or like 15 equals 2x, and then you solve for x. All that is called is deriving. So you're deriving different things of the equation. That's a generic term, not like specific to math. You're deriving different versions of the equation. And so these first 3 questions walk you through how to do them, and it gives you all the information. And then it does kind of cut off like weirdly, but it is what it is. And then just asks you to calculate a couple things. It is like 1-step equations. That's it. There's no like fancy x squared, cubed roots, nothing. Okay. So do keep that in mind. Bye, Felix. The only one I saw, the people I did turn it in, mess up on was this one down here. You have to understand what those 2 terms mean. Okay, I'm not going to give the answer because some of you still have to do it. So you.
Here's the answer.
Yeah.
I know the answer. Just like let them know.
You just
Yeah.
want to make sure it's correct.
Yeah. Okay. Show me your assignment and I'll double check.
All right, sure. I'll send it to you after.
If you want to see.
Okay. So you guys are brats. All right, and then just a couple questions. So you can refer to your textbook. You can Google as long as you don't copy and paste and you put it in your own words. This one, I'll still give credit either way. This one just says ecosystems. It doesn't specify terrestrial or aquatic, so I'm assuming all of them. But I think one person that turned it in just did terrestrial, but it's still fine. It was still correct as far as terrestrial biomes go. I feel like there was one other one too, but maybe not. Okay, so that was yesterday's assignment. I promise you I don't think it will take too long. But one thing I do want to show you guys, I'm going to make up numbers. These are not the right numbers. Don't copy them. Okay? I'm a what? I'm a horrible teacher? Thanks. Thanks, man. Oops. I keep mixing these 2 columns up.
You're trying to trick us. That's the correct answer.
No. The ones that did do it can verify this is not the correct answer.
Is it at least accurate?
Yeah, is your example accurate?
Yes, my example is accurate. Like I made those numbers there on purpose in the way that they're there, but it's not the actual answer. It has the same pattern. We'll put it that way. Okay, huh? And it's like the NPP and GPP online lab or video lab, something like that. All right, the one thing I do want to show you, I don't know if you know how to do this, or maybe even if some of you do or don't have access to it, it might differ by grade level, but it might make entering calculations like this a little bit easier. If you go to insert, dang it. Ah. Oh, he's watching the video. I was like, what the heck? Oops. Oh, here's KK. So if you go to insert, over here on this side, there's equation. Do you guys know about this?
No.
No?
Not until
So-
I implement.
Isn't that like, what's it called?
Equation editor? All right, so insert new equation, says type equation here. So if the R wasn't there, I'm gonna pretend it wasn't, I could have like R equals, this is really hard to read on my screen. I have a division symbol right here. So I could do my initial DO, which in this case was 9.5. And then it says subtract the dark dissolved oxygen, and that one was 5. And then the time in days, when you go through the experiment, you find out it's over 2 days. And then, oops, and then I could do equals and then put my answer. Hopefully you guys at least know your order of operations.
Please excuse my dear Aunt Sally.
Please excuse my dear Aunt Sally, right? Well, that works too. I don't think your sister likes that.
My very excellent mother just understood. Oh, that's for the planets.
Yeah, that one's for the planets.
I remember.
Milligrams per liter per day. And so you can start typing it in like this, and it even auto formatted it into fractions for me too, which it didn't used to back in the day. But like I said, this is not the correct answer. Those that did do it can promise, but it's the right format. All right. So hopefully that helps. Like I was able to catch one person's error for having the incorrect number up here. And then, you know, that I can fix. But sometimes if you just put the answer, it doesn't help me if you get it wrong, because I don't know where you went wrong or what part you don't understand. Okay. Equation editor is really nice. I'm surprised you got, well, most of your math is probably through that math program they got new this year, but that's how us old people have to do it in Word documents. I was doing this stuff before Google, man. All right. I did not have Google in high school. So that was the assignment that's yesterday. Get around to it. I did give extra time. It actually wasn't due till today. So, I mean, you guys still have time even to turn it in on time. Is there any questions about this other than me giving you purposely the wrong answer? Nope.
I did have a, what do you call it? A question for number 15.
For which one? Number 15?
No, 18.
18.
Yeah.
Which of the following represents the respiratory energy? This, I will tell you, is a subtraction. That's my hint.
Okay, because I didn't understand it today.
Man, I don't know what's a better hint.
Huh.
Say the answer.
But
Yeah,
how did
that's
so overall?
you refer back to these equations, so the ones that are in the boxes, right? Respiration rate. We learned not yesterday, the day before, NPP equals GPP minus R. So all this does is it gives you R equals, GPP equals, and NPP equals. So no matter what value you are given, you can use one of those 3 equations to get the missing one, right? So I'm trying to think of what to say, but that way, so you have, where's number 18? In the community described in the table above, which of the following represents the respiratory energy? So we're looking for respiratory energy, right? So you go back up here and you can look at this one, or you can do a subtraction between a couple numbers in here. My hint is going to be that you use producers, because we're not looking at consumers. Primary consumer would be like a rabbit. We don't measure photosynthesis in a rabbit, okay? So you're looking at the producer. Those are my hints. I want to see what you can get from it. And I think if you got this wrong, I actually commented on your assignment if you turned it in and got that one wrong. I tried to, at least. So KK, the equations, you use the data that you get. I made fake data right here. This is not the answers, but I made fake data, and you plug the numbers in the equations and you solve for it. That's all. One-step equation. All right. Any other questions? Then can I please have the answer key?
May I? have the answer?
No, you may not have the answer key.
Answer key for reward.
No, in Spanish doesn't work either.
I can say hi.
Okay, that just sounded creepy, Daryl. All right. You guys, I feel like you're making it out to be harder than it really is. I do promise you that.
I just don't feel like better.
Okay. That with the, what you told me your sleep schedule was like, I could understand that. But
Alex.
Done tomorrow.
You have
That's-
a computer charger?
Yeah.
yes, actually, because they haven't come picked up my computer yet.
Okay. We asked a long time ago.
Yeah, my computer broke on Tuesday. Probably because I got the tech guy in trouble. He won't fix my computer.
Here, miss. I'll trade you.
Oh, what, you're shining the laser in my face.
I did not shine it in your face. That's bad.
All right,
I tried shining it in Alex.
everyone ready to take notes now?
Yes, yes.
I know,
Now they're like close.
right.
Miss, can I just get paper? Please. You have a paper copy?
I can make you one for next week.
I'm done with this computer deal.
Close the window, let in the cold. Thermodynamics. What's it?
I have no idea what you were just talking about,
But
Leland.
yes.
Oh, I was reading the theme on here.
Oh, gotcha. Oh, yeah, that makes sense now. All right.
Oh, that's what I was looking for. For real.
Okay. All right. So we're going to talk about thermodynamics and energy flow. Hopefully you guys have heard of thermodynamics before.
Thermo.
Thermo is what?
Heat.
Good. It's heat. Dynamics, you can take a guess.
Hello.
It's the changing or the flow or the movement. Dynamic is usually movement.
Jesus Christ.
And no.
That I will tell you, thermodynamics was the first time I truly understood calculus, because it's like, we're not doing calculus, okay? But it's when I had to take like college chem classes and stuff, you do thermodynamics and you do all the math behind it, and it's calculus based. But it was applied, so it made sense. Applied physics, well, applied calculus. All right. So that is what we're going to be talking about today in energy flow through an ecosystem. Some of it you may feel is a little bit review. No! Oh my gosh, Daryl. Okay, so energy. Energy is the capacity to do work or transfer heat. Okay? Energy comes up in every single science. You have no energy to do your work. That sounds about right.
It's all that potential that we have stored.
Did this yesterday or Tuesday or whatever. All right, so you're going to find energy in biology. You're going to find energy. We talk about it in earth science. You talk about it in physics. You talk about it in chemistry. I was just reading something from Mr. Delhoy today that he's trying to put in a course proposal for a scuba diving class here at Sierra. So guess what? That is energy and a whole bunch of other stuff. Very, very heavy in chemistry and physics. So yeah, that's what it is. So we've got two types of energy. We have kinetic energy, which is moving with mass and velocity. So weight and speed is kind of what some people tend to think of. So wind, heat, electricity, water, things like that. But yes, anything that has a vector, that is correct. All right. Potential energy is stored energy. So that's kind of why you have this picture over here of the bike rider. He's putting energy in to go uphill. When he's at the top, it's a whole bunch of potential energy. You could also think of like a roller coaster. When you get to the crest to the top, and then they let go of you and you go flying down. That's energy going out of a system. Yeah, right. Everything's a roller coaster. What's up, Leland?
How come nobody really thinks deeply about this? Meaning, like, energy going in while you're going up a hill, technically you're spending all your energy because you're going up.
You're putting energy into the motion. Does that make sense?
Okay.
All right.
Yeah.
All right. So kinetic is some sort of movement, whether it's energy in or energy out. Potential is when it's got that final resting point. Like even throwing a ball in the air, it goes through its apex where it technically freezes for a moment and then drops back down. If you like vectors, you need to take physics. All right. The first law of thermodynamics: energy cannot be created nor destroyed. It can be changed from one form to another. All right. You probably would have dealt with this also a little bit in biology when it came to mass. Mass cannot be created or destroyed. It only gets changed from one form to the other. That's why you could potentially have the same cells and same atoms as a dinosaur.
You're telling me I could be a T-Rex?
Yes, if you will it into existence. That's what I always refer to myself because I have short arms. I'm a T-Rex. All right.
You're tall.
I'm tall. So your height is supposed to be the same as your wingspan, right? From tip to tip. So I'm actually shorter this way than I am this way. So that's why I call myself a T-Rex. Yeah.
You have the right to bear small arms.
Yes, I do. I'm bearing my small arms. All right. So just a couple of examples. You have ice cream melting, light energy into chemical energy. So you're moving from chemical to kinetic, light to chemical. So it's still all energy. It's just different forms.
What about children? They're created with energy.
Yes, but you have to eat foods and everything and those proteins and all those building blocks. All right. Second law of thermodynamics is the increase of entropy. Energy quality always decreases, and you'll see that in a little bit when we get to the food chains. When energy changes form, it is always degraded to a more dispersed form. A lot of it gets lost through heat. Energy efficiency is how much useful work is accomplished before it changes to its next form. So even though right now we're talking about like food and cellular energy, you could think of energy efficiency even in terms of, I was going to say energy, but that was a really bad, like electrical energy is another way, where how much of it is useful, how efficient is it?
I have no entropy.
Or do you have a lot of entropy?
No. This is the quality of my work.
The quality of your work is good. The turning in of your work is few and far between.
The quality is good. The quantity, not so much.
There you go.
Yeah, how'd you learn how to touch those house? Just practice.
Yeah, practice. My dad forced me, like at home, I would have to spend like an hour a day typing. He was not going to let me grow up without knowing how to type.
You know how slow I type?
And you still don't have to.
Yeah, you do.
I could type. I type better than these two.
I type faster than you.
Not by much.
I can type 5 words.
Mr. When I was pointing at it that way, I meant Mr. Disney, not you. Oh. No, Alex is a fast typer. You're a typer, though.
Ooh, so you're saying he has a lot of mistakes?
I'm pretty much the same way. I chicken peck, but I'm pretty fast.
You chicken peck, but you're fast.
I used to do that.
All right. So I know this says a lot, but it is what it is. All right, so sources of energy. You've got, how do I want to put this? All right, so high energy, or high quality energy, sorry, is concentrated and has a great ability to perform useful work. So that's where like electricity is up here. All right, nuclear fission, nuclear fusion. This is like how your sun is made right here. This is your uranium, your nuclear power plants. Concentrated sunlight, when you can aim all the solar beams in one spot, you get insane amounts of electricity. And then high velocity wind, which is good and bad. So these are all very high quality energies. And then all the way down here, you're looking at more the lower quality. It's not necessarily bad, but you're producing a lot of waste. So this is a good example, is the geothermal energy. So it's energy, it's heat coming from it within the earth. It's not destroying anything. It smells really bad, but it is what it is. But most of that energy is being lost into heat. It is geothermal, right? If you can't capture all of that heat, which it's really hard to, then it's going to be a low quality source of energy. Now, the entire country of Iceland runs off of it, but like Iceland has, 100,000 people on it, the island. So it's not like it's a whole bunch of people. I'm pretty sure there's more tourists than there is people that live there. That's Greenland. Oh, well, they're both, Iceland's tiny. You can drive around Iceland if it's not wintertime in like a day.
Isn't Iceland covered in volcanoes?
Iceland is the only island where there's a divergent boundary allowing magma to come up through. So everything else is a convergent boundary that's an island. So it's the only one where the plates are pulling apart and an island is still building.
Okay.
But it is what shuts down air travel all the time to Europe. So if you ever plan on booking tickets to Europe, make sure Iceland volcanoes are not active, because it clogs up the entire freaking atmosphere to get to Europe, and they cancel all the flights. Then, so as far as sources of energy, energy tasks, very high temperatures, process producing the electricity down to low. Efficiency, which is the like space heating, all of that. All right, moving on. How do stinking humans fit into this picture? So our enjoyment of life comes directly at the expense of polluting the environment. So typically the more goodies that we get, it typically pollutes the environment when it comes to cars, when it comes to heating houses, when it comes to making food. Food is like cattle and crops are extremely taxing on land and soil. So anything that makes us comfy is kind of like a thumbs down for the environment.
Every action has an equal and opposite reaction.
Kind of. All right, so we are technically kind of top predators, although I feel like the corona is now the top predator and we're all running scared like little rabbits into a bush. But everything that we do increases entropy by definition and makes our environment a little bit worse. So there we go. I think I went forward only one slide. All right, law of conservation of mass, because you haven't had enough laws yet. For any closed system, the mass must remain constant over time. We're not consuming resources, we're just borrowing them and transforming them. That's what I was talking about, how we could all have cells and atoms from, dinosaurs. You can need to find your inner dinosaur, right? We're just constantly being recycled, whether we want to be or not.
Someone asked me what happens when we die. You know what I'm gonna say? We all turn into birds.
There you go.
changes are right. We do need to pray.
Yeah.
Because our atoms, we can't lose any of them. We just move all over the place. So we reincarnate to one or multiple.
Yep.
Wait, you're telling me I'd be hundreds and hundreds of billion years old?
Yes. Well, not billions, millions, yes, because the universe is only 13.8 billion years old.
13.8 billion years old.
Yes, you could be that old. So yeah, look good for my age. All right. So where does matter go when it's burned? So like we have this picture of the wood burning pile right here. The wood turns to ash, so you get something that's left behind, but then you have the carbon from the wood turning into carbon dioxide, carbon monoxide, water vapor, all of that gets put into the atmosphere and eventually gets cycled back through the carbon cycle, the water cycle, and all that other stuff that we've talked about already. All the mass is conserved in some sort of way. So if it's not the ash, it's one of those other things. And then there's still the same number of atoms present. All right. What is the relevance to environmental science? This typically leads to pollution. Like we were talking with the last two slides at least. We'll always be faced with it as some sort. What kind is it and how do we reduce it? Those are ways that we have to work it out. I mean, if you think of like cameras and photography, back in, what was it, the 40s, if you needed a flash for your picture, it was one light bulb per flash. The light bulb broke every single time. So you would have to replace that light bulb anytime you needed to use the flash on your camera. We've learned how to make light bulbs last longer. That reduces pollution. That helps out. We throw the phones out at this point faster than we run through a flash bulb. So there's ways and things we can do to help reduce it. It's going to happen. We are going to pollute. How do we make the best of it? Yeah. Back in the day, I used to keep a brick cell phone in my glove box. Battery lasted all year long. All right, so here's something that you'll have to, we'll be talking about a little bit more. I don't know if we'll get to it today. 300 trout are needed to support one man for 1 year. The trout, in turn, must consume 90,000 frogs that must consume 27 million grasshoppers that live off 1,000 tons of grass. So by eating what you eat for a year, you're consuming 1,000 tons of grass, 27 million grasshoppers, and 90,000 frogs.
Wow.
Right?
Thought of it
So little did you guys know you had such a good appetite. All right, so this is talking about food pyramids. So some of you guys put those in your biome presentations last week. This is why the bottom part of your pyramid was so big, 1,000 tons of grass. That's a lot of biomass, right? To feed 27 million grasshoppers, and those grasshoppers feed the 90,000 frogs. And do you see how it gets smaller as you go up? Same with the pyramid.
Yeah.
Those are some pretty big numbers. All right. So in your packets, it should be like terms are left blank and definitions are on the right side of the table. They are not in order. So I'm going to read through some definitions and you can tell me like what box number or whatever if you want. So only eats an animal that it has killed is a predator. So you have your shark, you have your cat hunting your mouse because it's just funny, and you have your lions probably eating elk or buffalo or something yummy.
Wait, what? Can you repeat that again?
So predators only eat animals that it has killed. So it isn't they don't go in order. So you are going to have to look for that.
Okay, I have.
It is number 7. Good, Daryl. It is number 7. Is a predator. Dang. My mom's cat used to bring in hummingbirds, crows, squirrels, mice, snakes, spiders, lizards. She'd bring everything in the house.
How did a cat manage to kill a snake?
Snake is easier to catch than a hummingbird. Have you seen how fast those fly?
Yes. Only in videos though.
Huh? All right, next one is an omnivore. They may eat plants or animals. They can eat meat, yeah. Trash panda to the left. A bandit panda. I like trash panda. But bandit panda is accurate too. They may eat plants or animals. That is an omnivore. I am an omnivore. I eat both. Just like bears eat fish as well as berries.
Can you repeat that again? I was doing something real quick.
Omnivores may eat plants or animals. Number
Okay,
5,
I got that one.
according to Daryl.
All right, I got that one.
Okay.
Thank you.
All right, organisms that can only obtain energy by eating other organisms. They're called 2 names. One of them is called a consumer because they're consuming, or heterotroph. Hetero means different, troph means food. So they're eating different foods or a different food source. So consumer or heterotroph.
Number 2.
Is number 2. Good, Leland. All right. Next one, decomposer. Breaks down organic matter to inorganic compounds. Only bacteria and fungi belong to this group. And number 8. Very good. All right. Next one, producers and autotrophs. Whoa. Organisms that can produce their own energy through photosynthesis or chemosynthesis. Number 1, good. So you've got like cyanobacteria. It's known as blue-green algae sometimes, even though it's photosynthesizing bacteria, which is that picture right here. They consider this being the reason that we have oxygen in our atmosphere before there were any animals or plants ever around on Earth. Huh? It is not an animal. You did not pay attention in my biology class, young man. All right. All right, so you have a whole lot of different things here. You have your algae, you have your trees, stuff like that. But you guys got it, so I'm going to keep going in the interest of time. Primary consumer. Bottom right is a copepod, so he's one of the things you would find in the ocean. It's a type of zooplankton. You're looking for the second level of a food chain. It only eats producers. So even though it's the second level, it's still called primary. It is number 3. That is correct. Sometimes. All right, next one, detrivores. So these organisms break down dead organisms and feces into smaller organic molecules, includes earthworms, sea stars, pill bugs, flies, all of that. Slugs, since he's in that picture, slimy slug. All of these guys are called detrivores.
That is ugly.
You just hurt its feelings, Leland.
Does it have feelings?
How do you know it doesn't?
Exactly.
All right, that
don't know.
one should be number 9. I heard somebody say it, but I think I ignored them. Carnivore, only eats animals. Yep, number 6. Next one, secondary consumer. They're the only one that should be left, exactly, the 3rd level in a food chain. And we'll go over, it'll probably make a little more sense when we do the pictures, but we'll save that for next week. It is about time to go. You've got like 1 minute left of class. So I am going to stop right there.
Okay.
Yeah, you are now my new folder.
I can't.
You need to do some homework in there, my friend.
Me too, buddy. Me too.
All right, so that's gonna be it for today. Like I said, we weren't gonna get through all of it, so I'm not gonna give you guys a DOL today. Do finish that online video lab if you didn't do it already, and I shall regrade yours. Is that for
Where'd you
me?
get those from?
Thank you.
Miss B,
Yes, what's up?
on my video lab, how did I do overall?
I think you only got one question wrong, so it was very good. Very good. Bye. See you guys next week.
The test of all tests.
Bye. Happy Halloween.
Bye. Hi.
Hello. You came after me and I thought someone was
You're doing better than Felix.
Yeah, miss, I'm sorry.
Have a happy Halloween too.
I think Alex saw me fall asleep. So it looks like me.
Probably.
Got it.
Ugh. My parents were right.
What?
They told me not to come.
Oh. Well, you've just got study hall left. Do you still need it?
I'm sorry.
Okay.
I don't know how to put this back.
Wow, you're bad kid. Can you put a skateboard back?
I fell asleep, bruh.
I haven't even gone to sleep yet. I don't want to hear it.
I'm tired. I'm live.
My legs are losing.